two, okay, we have taken this particular thing, Ethernet. When we are going to talk about a LAN, when we are going to talk about a LAN, or when we are going to talk about a MAN, okay. So we discussed that under the LAN or MAN when we are going to talk about, okay, so how it is going to be done. So now we have taken the LAN. Under the LAN, now the first we discussed that Ethernet. So Ethernet standard format is what, IEEE 802.3, and this Ethernet is going to implement your CSMA by CD. I have already told in the yesterday's class, okay, which is going to implement CSMA by CD. Okay, so this we have already discussed that what is CSMA by CD and all. But when it will comes to that, how this Ethernet is going to provide that. So now when you are going to look at your OSI model, we are going to have everything, it is divided into physical layer, and then we are going to have the MAC sublayer. Okay, so data link layer. Under that particular data link layer, what we said, it is subdivided into two parts. Okay, one is LLC and another one is, we discussed that another one is MAC. Another one is MAC, medium access control. So now when we are going to talk about a LLC layer and MAC sublayer, this MAC sublayer is going to deal with your physical things, and whereas your LLC is going to discuss with deal with the upper layer. Now in this particular thing, we have seen that how it is going to be happen. Now here if you are going to look at that, your this data link layer is divided into LLC and MAC, and for every type of your network, okay, it is going to use its own data link MAC. Okay, so like if suppose you are going to talk about Ethernet physical, it is going to use Ethernet MAC. If it is a token ring physical layer, then it is going to use the token ring MAC. It is going to be token bus, it is going to be token bus. Like this, you need to understand over here. So then we discussed that, okay, what would be the frame format, how it is going to communicate the data and all. Okay, so now when we are going to talk about the data, how it is going to be communicated and all, so where we discussed that, so a frame format, it is going to contain the address. Okay, now here we are going to have two addresses. One is the destination's address and another one is the source address. Okay, so we need a destination address, we need a source address. Each one is a 6 bytes because it is going to use a MAC, 6 bytes, and control when we are going to talk about, and here we are going to use the control, so where we are going to have type fields also, and this is the data which we have discussed the data. Okay, so minimum to maximum, so here we have taken the minimum as 16 and maximum as, okay, so anyhow that we will have a look at. So then we are going to have a FCS. So when we are going to talk about a FCS, okay, so here we are going to talk about again 4, okay, 4 bytes. So 32-bit CRC we are going to use now. So based upon that, now here we have discussed that how it is going to be implemented, how it is going to be implemented. So this protocol, when we are going to talk about, so this is going to be coming to the two variations as yesterday we discussed. One is the HDLC and another one is the point-to-point protocol. Now when we are going to talk about this HDLC protocol and PPP protocol, which I have already shown to you people in the previous class, okay, how it is going to be happen. Now let me open that. Okay, 1 minute. So now here when we are going to look at the frame format and how it is going to be happen, yesterday I have told that always it is going to have a preamble. Always it is going to have preamble. What is the meaning of a preamble? So it need the starting some synchronization bits should be there, and after that we are going to keep the flag, isn't it, which is going to be used to identify for the starting of the frame. Okay, so now here if you are going to look at, this is the introduction we have seen. Now here if you are going to look at that, this is going to be the starting of that. Then we are going to have address. We are going to have, so address is going to be for the source and destination we said. Then we are going to have control. Then we are going to have the checksum, and here we are going to have the ending of the flag. Okay, sequence. This is a bit oriented protocol. That was the reason we are representing 061 zeros, okay, to identify the frame starting and frame ending. But ultimately, when we are going to look at, okay, now here if you can have a look at that, how this particular standard Ethernet frame, okay, when we are going to talk about the standard Ethernet frame format, how it is going to be happen. So when you are going to talk about the standard Ethernet, which this Ethernet is evolved in 4 versions, okay, 4 generations, we can say that 4 versions or 4 generations. And so which is gone through with the 4 generations, like it is initial one is named as standard Ethernet, then next one is the fast Ethernet, next one is the gigabit Ethernet, next one is the 10 gigabit Ethernet. Dear friends, when you will enter into the field, so maybe you can have a look at 10 gigabit, but as of today, we are limited up to this particular thing, 10 Mbps, 100 Mbps, and 1 Gbps speed. And this is a 10 Gbps speed, which we are going to achieve in that particular thing. So now in these 4 generations, when we are going to use these particular Ethernet networks, how the data is going to be exchanged in the form of frames. Okay, so which frame, which we are going to talk about that, this is a 802.3 Ethernet is known as 802.3. We are going to call it as Ethernet. Okay, you can please keep it in your mind whenever I am going to talk about Ethernet. Okay, so Ethernet, whenever I am going to talk about, immediately you need to get back this 802.3 in your mind. So now when we are going to talk about this 802.3 MAC frame, okay, so now we are going to have a preamble. I said for the synchronization purpose, you need to send 56 bits of zeros and ones. Okay, after that, you are going to send your start frame delimiter. Okay, your start frame delimiter. So that is 101010, then 11. So now from here onwards, it will start. It will indicate that. See, this is 7 byte, this is 1 byte, and now this is the one particular things you need to use that. This is a so preamble and this. Then you are going to have destination address, as I told, that 6 bytes, source address 6 bytes, and then control field is length or type is 2 bytes, and CRC is 4 bytes. Now this complete together, how many? 6, 6, 12, 14, and 18. 18 bytes is compulsory, which you need to keep it in your mind. This 18 bytes is must and should in your frame. Okay, so then when we are going to talk about this data and padding, when we are going to talk about this payload, okay, when we are going to talk about this payload, when it will comes to the 802.3 frame, the minimum and maximum lengths are there. So minimum is 46 and maximum is 1500 bytes of data in one single frame. So yesterday we discussed that now that is nothing but 46 plus 652 plus 658 plus 260 plus 464. Now that is nothing but, so minimum a frame should have how many bytes? 64 bytes compulsory, and maximum how much? So 18 bytes, which we have discussed that. Then based upon that, I'm not going to waste much time, just I'm bringing you people into the today's class so that you can understand in a very well manner. Okay, so now based on this particular frame format, so what we discussed that to process that, this is a MAC address which we discussed that, okay, 6 bytes, okay, 48 bits which we are going to use, and the addresses are going to be unicast or multicast, how it is going to be done, then all that we have discussed that. Then so ultimately when it will comes to that, now the standard Ethernet, when we are going to look at that, in each and every Ethernet, it is going to follow the different technology, different connecting modes, different cables. Okay, because we have discussed about various topologies. Okay, various, and we discussed about various topologies. Then we discussed about various mediums. Okay, wired medium, wireless medium, and where in the mediums we are going to be, we had discussed various cables. Okay, and then how those are going to be connected. Okay, so how those are going to be connected. So in that particular situation, it will be the very important aspect to understand when I am going to talk about this standard Ethernet, which is going to be used if I am going to use one type, which topology I am going to use, and which medium I am going to use, and which, how to connect this particular thing, what is the limitation, like how much distance that medium can be used, and which for which medium which type of connector I can use it and to connect it, and what are the advantages and disadvantages. Now, dear friends, here if you are going to look at that standard Ethernet, we are going to have four different types of implementation. Four different types of implementation. What are those four? 10 base 5, 10 base 2, 10 base T, 10 base F. And please try to remember, this is the network which is going to provide 10 Mbps, 10 Mbps speed only, as you can see over here, which I have shown that. Okay, so the speed of this particular thing is 10 Mbps, and then 100, then 1 GB, then 10 Gbps. So according to that, when we are going to get only the 10 Mbps, that was the reason this is 10. So you may question, sir, that is nothing but in the next one, the fast Ethernet, we are going to have 100. Then in the gigabit, we are going to have different. Yes, you will come to know that. Okay. So now here, when you are going to look at the 10 base 5, what we are going to talk about 10 base 5 cabling. Okay. We are going to popularly call it as thick Ethernet, thick Ethernet, and which makes every 2.5 meters to show where the taps go. Okay, so now here if you are going to look at that, okay, so here I have shown that, see, thick Ethernet, okay, thick coaxial cable which cannot be bent, and for every 2.5 meter, okay, here which you are going to talk about, every 2.5 meter it is going to show that where the tap should go. Okay, so like that, this is going to be there, and connections to it are generally made using vampire taps. Vampire taps. Yesterday I told that in the 10 base 2, okay, in the 10 base 2 we are going to use the T connectors. Okay, in the 10 base 5, this particular thing is going to be called as a tap. Okay, so this we are going to call it as a tap, and this tap we are going to call it as vampire tap. Please note down. So in the 10 base 5, we are going to use vampire taps, and in which a pin is very carefully forced halfway into the coaxial cable core. Now, what is the meaning of that? Okay, now here if you are going to look at that, okay, I'm going to keep it something like this. Okay, and here I'm going to keep this particular thing is like this. Okay, now here this particular cable is there. Now a pin will come and it will touch inside this particular cable. Okay, so this you need to understand very well. So this is what exactly the meaning of vampire taps, in which a pin, okay, a pin is going to be pressed into that, and which is going to be connected forced halfway. See, you can have a look at that. I'm not okay. So 1 minute again. Once again, I'm going to draw it. You can have a look at. Okay. So now let us consider. I'm going to draw this particular thing. Okay. Now let us consider, if I'm going to draw like this, and here if suppose we are going to have this particular thing. Now whenever I'm going to use a tap, halfway, that is nothing but up to this only. Now here it is not coming, you see, the pin is not coming over here, the pin is not touching this part. That is the reason I'm going to call it as halfway. Okay, so this is what we will call it as, that in the vampire taps, how it is going to be connected. And then the notation 10 base 5, what is the meaning of 10 base 5? I told that, okay, in the 10 base 5, the speed is 10 Mbps, and maximum length of the cable is 500, and which is going to use the baseband. Okay, now you can have a look at that. Means it operates at 10 Mbps, uses baseband signaling, and can support segments up to 500 meters. Okay, so finally, if the medium is coaxial, its length is given rounded to units of 100 meter after base. Okay, so this is how exactly the 10 base 5 which is going to be done, and how we are going to connect it. Now you can have a look at over here. You can have a look at over here how it is connected. How it is connected. Okay, so this is what exactly we are going to call it as a vampire tap. We are going to call it as a vampire tap. Okay, so then we are going to have what? 10 base 2. In the 10 base 2, now what we are going to say in the 10 base 2, the second type is 10 base 2, which is going to have a, so thin Ethernet. Sorry, thin Ethernet. Here I did a mistake. Okay, this is not a thick. Okay, fine. This is correct only. Which in contrast to the thick Ethernet, okay, bends easily. So here, if you are going to look at in this above diagram, so this cable cannot be easily bendable. It is not easily bendable. Not easily bendable. Okay. So it is not easily bendable. But when it will comes to our this particular part, okay, now here if you are going to look at that, yesterday I explained. So this is the thin coaxial cable which can be bent, okay, easily bend per that particular thing. So now when we are going to connect to you, we are going to use the BNC T connectors. We are going to use the BNC connectors to form T junctions. Okay, so that is what you are going to look at over here. Okay, so this is what exactly we are going to call it as BNC connector. The three scientists who have made this particular connector, based on their names, it has been called as BNC T connector. BNC T connector. So when you are going to look at that, it is going to look like a T, you see. So this is how it is going to look like T. So that was the reason we will call it as a BNC T connector. Okay. So now when we are going to use the thin Ethernet is much cheaper also and easier to install because it is easily bendable, but which can run only for 185 meters and maximum you can handle only 30 machines. So now that is nothing but in our colleges or universities, small labs which are having the 30 machines can use this particular kind of cabling and this kind of network to support 10 Mbps speed. Okay, 10 Mbps speed. So this is what exactly we are going to talk about that. So then when it will comes to that, next one is what, 10 base T. When we are going to talk about a 10 base T, we are going to use a twisted pair cable. Okay, so but in the 10 base 2, what is going to be happen, little disadvantage is there. In the T connections, what is going to be happen in the sense, in middle, if one particular T connection connector is failed, there is a problem. See, detecting cable breaks. Okay, so excessive length, bad taps or loose connectors can be a major problem with this, with both media. So now for this reason, so we are going to move to the next one. Okay, so now here for that particular purpose we will move to the 10 base T twisted pair, in which all stations have a cable running to a central hub. How you can have a look at that, all cables are. So now in this case, what is happening, if any problem with this will not affect to these two. Okay, but if the problem is happening to this, then it is going to be affected to everything. So in the 10 base T, these wires are the telephone company twisted pair wires. Okay, since most office buildings are already wired, it is easy. Okay, cheaper. Now this we are going to call it as the 10 base T, and so hubs do not buffer the incoming traffic. This you need to remember. So always whatever you are going to get, okay, from here, so immediately if this particular thing is supposed to send it to this particular system, simply it is coming over here, it will never buffer it and simply it will connect it to this. Okay, that is the duty of your 10 base T hub, and or we will look at that hub and everything. So this is what exactly we have discussed in that particular 10 base T. So now here, when it is a hub, so it is quite simple. Adding and removing the station is quite simple, and cable breaks can be easily detected, because which is not working easily you can identify by checking that hub at each port it is going to have a light blinking. Okay, so if it is not blinking, that is nothing but there is a problem with that particular cable, only that particular thing you can do that. Okay, and another important point is all are the point to point, so there is no shared cable at all. Okay, so easily only that particular system. That's what I mentioned, that if one particular system is affected, then nothing is going to be happen with the other things. Only the disadvantage is that the maximum cable run from the hub is only 100 meters. Maybe if you are going to take some cat 5 or cat 6, maybe you can go up to the 200 meters or some, okay, more that. But okay, so we are going to use cat 5, but now we are changed these particular things to cat 6 also. We are using cat 6 in our labs. We are using the cat 6 cable over here. Okay, so this is 10 base T. So same way we are going to have fiber optic 10 base 5. Okay. The fourth cabling option is Ethernet 10 base 5. This is alternate and which is expensive and which is fast. Okay. So the cost is cost of the connectors and terminators. Because of that, so it is little expensive, and but which is going to have excellent noise immunity. Fiber optic, which we have already discussed, that which is having more advantages than that. Okay. So this method of choice when running between the, this is a choice of the method when you are going to connect the networks between the buildings and okay, widespread widely separated hops, okay, with a distance. Okay, then it will be a very important method, and which can be used up to kilometers. Okay, so now this is a very important, but ultimately, so tapping is very difficult because you cannot easily do that, because fiber optic is made up with a glass, and which we have seen how it is going to be used connectors. We have discussed that various SC connector, ST connectors. Okay, so based on that connectors, so it is very difficult because the internal core cladding is going to be made up of with a glass, and this is some, it is not like that. Okay, the coaxial cable, just you take a pin and connect it into that and get the data, but you cannot do that particular thing over here. Okay, so that was the reason I'm going to say that good security. Okay, since white tapping wiretapping, since wiretapping fiber is much more difficult than wiretapping in copper wire. Okay, so how we are going to do that particular thing? So this is what exactly we are going to talk about in this 5. So dear friends, now this is the summary which we have seen yesterday. So based upon that, you are going to connect this particular thing. Okay, so for connecting, you are going to have that, see, 10 Mbps standard Ethernet has gone through several changes before moving to the higher data rates. These changes actually opened to the road to the evaluation of Ethernet to become compatible with the high data rate LANs. How? The point is, we are going to have bridged Ethernet, switched Ethernet, full duplex Ethernet. Now, that is nothing but what are these things? Okay, just we will come back. But before that particular thing, just let me complete this particular part. Okay, fast Ethernet. When you are going to talk about a fast Ethernet, so we are going to have again the MAC sublayer. So here we are going to have 100 base TX, 100 base FX, 100 base T4. We are going to use 2 wire, 4 wires. Okay, so like this we are going to use in the fast Ethernet and different encoding techniques, and then we are going to use the gigabit Ethernet. Okay, and the same way 10 gigabit Ethernet. In the gigabit Ethernet, we are going to have again the various topologies and how you are going to connect it. And then we are going to have 1000 base SX, 1000 base LX, 1000 base CX, 1000 base T. Okay, now which cables we are going to use and how it is going to be happen, what is the encoding techniques. And then when it will comes to that 10 gigabit also, which we are going to use, that is 10G, we are going to use the format 10G base S. Okay, so but ultimately when it will comes to this is a Ethernet and all, but how we are going to do that? Okay, now here when you are going to look at that bridged or switched network, okay, so ultimately my intention is how we are going to do that. So dear friends, now the question is going to be arised. Okay, everyone please try to concentrate on that particular thing. So now we are going to have the standard Ethernet, fast Ethernet, gigabit Ethernet, 10 gigabit Ethernet, or whatever is the Ethernet. Okay, so we discussed the protocols and how these protocols are going to be used to the Ethernet. We discussed it. Now, when we are going to use the Ethernet, we discussed that what are the things were there. One particular thing we have looked at the full-fledgedly, but how it is going to be connected. Okay, so now here the question is very quite simple. Okay, so Now my question is, when we are going to talk about, so this is a very, very important topic which you need to remember. So again, I am going to tell you that, sir, you are always telling that whether if we will learn this particular subject. See, again, I am going to tell you that this subject is going to give a job. Recently, your seniors who have placed in the mind tree, okay, you can ask them what are the questions they have asked in the interview. All the questions majorly in the networks only. And you can ask your senior who has missed the opportunity of a 20 lakh package in Amazon because they have asked the questions in depth in the network, which he personally he was spoke to me and he was shared, sir, whatever the concept we have discussed in the class, those concepts only they have asked, but really in depth they have asked. Dear friends, what I am telling you in the sense, once if you learn this one, once if you will listen to the classes, after that you need to work on that. So you need to try to explore yourself more and more so that it is going to give a job. Definitely, damn sure, I am telling that this network is going to play a very important role, because without network, now you will understand that. Okay, so now imagine when we are going to talk about a particular university or any particular thing. So all the networks are going to have the same type. All the networks are going to have the same type. Never we are going to have the same type of networks which are going to be available. So when already we had a discussion that never every network is going to have same type, then in that particular situation, what is going to be happen? We have discussed that the frame formats are going to be dependent on that particular type of networks. Your frame formats are going to be depend on the type of your network which you are going to use. Okay, if you are using different networks, so different frame format. So in that particular situation, the question arises how to interconnect at different layers, how to interconnect these particular networks. Okay, then so we are going to discuss the what is the meaning of a transparent grid and what is the meaning of a spanning tree algorithm, so that you can have a look at that virtual LAN, which is a very, very important in today's aspect. Okay, so now interconnecting LANs. Why we need to interconnecting LANs? Now imagine anyone can tell me that debugging 1,000 lines is easy or 10 lines is easy. Anyone can respond, please?
10 lines, sir.
Absolutely, because now the point what you are mentioning is absolutely correct, Srikar. But when we are going to look at that 1,000 lines, how we are going to handle the efficiency is going to come down. Now here, if you are going to look at that, when too many machines are in a single LAN, the bandwidth may not be sufficient to support all the machines. Okay, so we need to partition one LAN into multiple LANs to get higher aggregate throughput. Okay, now this is what exactly you need to understand, that why we need switching. Okay, so a single LAN, if it is there, imagine 1 Gbps is there. If suppose 100 systems are there, 1 by 1 Gbps by 100 is going to get. But my intention is 1 Gbps everyone should get. So now here you can have a look at that 1 Gbps for all machines versus 1 Gbps for each machine. Which one we want? Which one we want? 1 Gbps for all machines or 1 Gbps for every machine?
Sir, every machine.
Then how? Then how we can do that? How we can improve the performance? Now that is what exactly I am going to explain now. So now that is one particular question. Okay, this is one particular question which you can keep it in your mind. Then next one is when the area is too big for a single LAN. Okay, so that is example 5 kilometers for Ethernet. We have discussed that never Ethernet is going to work for the 5 kilometers or like that. So in that particular situations, what we can expect? Collisions. What we can expect? Collisions. Okay, what we can expect? Dropping of that. So in that particular situations, we can create multiple collision domains and interconnect the LANs. Okay, so this is the second one. Okay, then For security reasons, Ethernet cards support a promiscuous mode. Please, very important. This one you need to understand, dear friends. Anyone knows about this? Uday? Uday, you are available?
Yes, sir.
What is this promiscuous code?
Don't know, sir.
You did a course, it seems, no?
Uh,
Dear friends, everyone, please try to understand that we are using whatever the laptop or your workstation which you are purchased, which you are using it, it is containing the Ethernet card. Okay, and your Ethernet card supports promiscuous code. Now, let me, without wasting my time or your time, we would like to see that promiscuous code. Okay, promiscuous mode meaning. So everyone, please look at over here. Anyone can read this, what exactly you are going to look at over here? Uday, can you read?
yes, sir. In computer networking, promiscuous mode is a mode for a wired network interface controller or wired network interface controller, wireless internet, wireless network interface controller that causes the controller all traffic it receives the central processing unit rather than passing only the frames that the controller is specifically programmed to receive.
So now you can understand that whether you have understood anything from this. Uday, have you understood?
Yes, sir. Instead of passing only certain parts of the data, it transfers all the traffic, all the through the CPU.
Now you are getting in point. So now the point is what is happening in the sense with this particular thing, attacks may happen because your Ethernet itself is having this promiscuous code which is going to pass all the traffic to it receives to the central processing unit rather than passing only the frames to the controller is specifically programmed to receive. It is not the case. That was the reason. So the attackers may have a chance to interpret and intercept, and they can get that particular thing. So now here, if you are going to look at that, your network interface cards, when you are going to look at that in a network, promiscuous code allows a network device to intercept and read each network packet that arrives in its entirely. Dear friends, please try to remember that. That was the reason. See, this mode of operation is sometimes given a network snoop server that captures and saves all packets for analysis. Okay, now this is a very important one, the network snoop. Okay, so anyhow, that is the other concept, but you please try to keep it in your mind. Okay, so for security reasons, okay, so which allows the stations to get all frames received, okay, because of this promiscuous code. Now,
Sir, is this a positive part of it or a negative part of it?
uh, it is
Like,
positive only for our networking purpose when we are going to look at that. We
okay,
are
sir.
going to explain that because now how Ethernet is going to work, how when you are connecting the two networks, one particular network node is sending the data frames to the node which is available in another LAN. Okay, so how these two should be joined and how it is going to be stored and forward in that particular mechanism, this promiscuous mode is going to help us in distributing. Okay, but there is a concern also. Okay, that is the reason we need to use some extra patches like firewalls and other things. Okay, which should not be access to the unauthorized people and all. So that is again at the user level you need to take out. That is the reason I have already told that network layer, network is unreliable. Network is unreliable.
Okay.
Okay. So now when we are going to look at that, okay. Now I want to interconnecting the LANs because of these particular things. Why? Okay. 1, 2, 3. I want to interconnect the LANs. But when I want to interconnect the LANs, challenge which we have discussed is that in the challenge what we said, there are so many different types of networks are available. Which network is going to use which topology, which medium, what type of architecture, we do not know. But still, our main goal is to connect and transmit it to that. So in that particular situation, we are going to use devices, interconnecting devices at different layers. Okay. When you are going to talk about the physical layer, we are going to use the repeaters and hubs. Okay. So if you want to look at the repeaters and hubs, if you want to try to understand, okay, what is the repeater, how it is going to work, and okay, just I will show you. So how you are going to connect these particular LANs? Now, when you are going to look at that, we are going to have passive hubs, active hubs, bridges, okay, and all those particular things. So everyone, please, you need to take a snapshot of this particular thing, or you can look at and keep it in your mind for later discussions. Now, whenever you are going to look at the physical layer, now here you can have a look at, okay, repeater or hub. Whenever you are talking about a data link layer, bridge or two-layer switch, whenever you are talking about a network, this is a router, and whenever you are talking about above the network, okay, so we are going to discuss about the gateway. Okay, so this is what exactly is going to be happen. Okay, so 5 categories of connecting devices which we are going to use. What are those 5? Passive hub, repeater or hub, bridge, router, gateway. 1, 2, 3, 4, 5. Okay. So now when you are going to look at that, what is a repeater? Okay. Now here if you are going to look at that, a repeater connecting 2 segments of a LAN. Now here if you are going to look at that, so this is one particular segment 1, it is coming over here, and so this is a repeater which is coming over here, and then so this segment 1 and segment 2 is connected. Now here if you are going to look at that, a repeater connecting 2 segments of a LAN. Okay, in the same LAN, okay, we are connecting. So this is the repeater, how we are going to do that. Okay, now a repeater connects the segments of a LAN. Okay, so but a repeater forwards every frame, it has no filtering capability. See, it is coming over here, it is going over here, that's it. No filtration, no checking, nothing is going to be happen over here. Okay, so now a repeater is a regenerator, not an amplifier. Regenerator, please try to keep this in your mind. Regenerator, it is coming over here, it is regenerating and it is sending it, that's it. Okay, so now this is going to be known as a regenerator. Now when it will comes to that, okay, so functions of a repeater, now you can have a look at that. See, this is a corrupted signal if it is coming. So your repeater is going to regenerate the signal and it is going to send it. That is the reason I am going to say it as a regenerated signal from right to left transmission or left to right transmission or whatever it may be, you are going to take about that. Okay, so now this is how it is going to be happen. But now that is we are going to use the repeaters or hubs up to the physical layer. What it is going to do, copy signals from one network to another network. It is not going to do any filtration, it is not going to have any knowledge, it is not going to check anything. But the next one, when we are going to look at that, bridges or switches, which is going to be dealt by data link layer. What it is going to do, selectively copy frames from one network to another network. Okay, so selectively copy the frame, copying of the frames from one network to another network, how it is going to be happen. Now the point is very, very interestingly, the bridges are going to play a very important role over here. Okay, so then when we are going to look at that, okay, routers are network layer gateways. So routers are going to be used at the network layer, and which is going to deal with the routing and forwarding. So how it should be routed and what should be the shortest route it should take, and everything it is going to be taken care. Now then another one next, when we are going to talk about application gateway, so which is going to be dealt by your application layer, and which is going to translate between your OSI and the other components. Okay, we will look at that one by one. Now the question arises, the main difference among repeater or hub, bridge or switch, and router. Okay, so this is a one particular question. Anyone can answer what is the difference between this repeater, bridge, and router?
The repeater copies the signal as it is, but
Okay.
the gets to select which frames it has to copy. And the router will direct the network through through the shortest route.
Uday,
Yes, sir.
some part is okay, but not correct.
Okay.
Now look at over here. I have told that first one is the repeater. When I am going to talk about a repeater, if you look at that, this came over here like this, and here like this, and like this, and this is the thing followed. Okay.
Yes.
But when I'm going to talk about a bridge, let us consider this is something, a LAN. From a LAN, a frame is coming, and here you have a bridge. Okay. And here you are going to have a wireless LAN. Okay. Or otherwise other topology. This is something wireless LAN. Let us consider. Now, this frame and this frame is going to be changed, no? Isn't it or not?
Yes.
Now, you see, your bridge need to do this part. It is supposed to convert. Okay. But when
So
we are
from
going,
one format to other format, the bridge will convert it.
yes, it need to filter and it need to cross verify and all.
Okay.
But when we are going to talk about a router, so there is a small difference between your bridge and router, because your bridge is limit up to the data link layer. Now your data link layer is going to deal with the physical address. What I said? Physical address. What is the meaning of physical address? Only the MAC address. Okay. So only the MAC address is nothing but this physical address. When I am going to deal, once if you are coming to the my network only, I am going to have this. Okay. So now the point is, these two LANs are connected in a single network. In a single network, you are going to have multiple LANs. As we discussed, just now in our college, we are going to have technology hub, tech drome, okay, CAD CAM lab, okay. So various LAN, small LANs we have created, and all these LANs we have combined. If you are going to take a university, in the university, one department is going to have one particular type of network LANs, okay. Another department is going to have. When you are connecting all these departments, now there only you are going to have the bridges. But when it is outside, between the different networks, how it should be routed, how it should be connected, that is what exactly we are going to talk about router. Is it clear now?
Yes, sir.
Okay, now let us have a look at. Now you can have a look at. Everyone, please take a snapshot or please keep it in your mind. Now, what is the repeater? So, which is a physical layer device, sees ones and zeros, namely forward what it sees in a port to all other ports. Nothing change. Whatever it is getting, it is forwarding it. Okay. Now, switch, when you are going to talk about a bridge, see, always you please keep it in your mind, either I'm going to use it as a bridge as a term, or otherwise switch as a term. Okay, you can keep that in your mind. So data link layer devices sees frames with layer 2 destination address in a port, and may forward a frame only to the port towards the layer 2 destination. Understood? So filtering is happening. Filtering is happening. So it is taking it, it is looking at that, and it is forwarding it. Then network layer sees packets with IP destination addresses and route the packets forward the layer 3 addresses. Now that is nothing but IP addresses. Now these are the logical addresses which we are going to talk about, and here we are going to talk about it as a MAC addresses. Okay. Now if you are going to think this one, so how it is going to be happen and all, so now here you can have a look at, I am going to show you, these are the hubs, how we are going to hierarchy hubs you are going to do. See, these are the three systems you are connected to a hub, and this is internally it is connected to this, and here we are going to call each one as these particular things as ports. Okay, we are going to call these as ports. Okay, so now here a bridge has a table used in filtering decisions. As I told that a bridge is going to filter it to whom it should send and all, it is going to have a table. So always when you are going to look at over here, we are going to have two different types of tables. One is the what we will call it as a transparent table, and another one we are going to have. Okay, now here when we are going to look at the transparent, now here you can have a look at that, a bridge connecting two LANs, a bridge connecting two LANs. Now here if you are going to look at that, which is going to have the addresses and which is going to have which port it is going to have, and based upon that it is going to send it. Now here if you are going to look at that, so in the LAN 1 and this is a LAN 2, both are joined by using a bridge with different ports. This bridge is going to be connected with port 1 and port 2. LAN 2 is connected to port 2, LAN 1 is connected to port 1, and now here this is a physical address. See, MAC addresses are there. By using the MAC address, it is going to identify. And now here when you are going to look at this address, okay, so it is going to look at, okay, if this particular station wants to send to this particular station. Now what is going to be happen? The port 1, okay, this has to be forwarded to the port 2. Okay, so how it is going to be happen? See, a bridge does not change any physical address in a frame. And here if you are going to look at that, how it is going to be happen? See, a learning bridge. A bridge is supposed to learn by itself. Okay, so and the process of learning, how it is going to be happen? See, here if you are going to have three LANs, LAN 1, LAN 2, LAN 3. Now this is the original. Initially it is not having anything. Now it has to learn, it has to generate, it should self-learn that thing. Whenever I'm switching on the network, it should create its table. Then only it can process. Now it is adding the port address A. Okay, I'm talking about address A. And this address A is connected to which port? Port 1. So this is the port 1. Okay, then so after A sends a frame to D, now here we need to understand that, okay, how it is going to be happen. So we are going to take that if suppose, okay, let us consider 15.6 diagram, what they are talking about. Now here, if we come over here, 15.6, see, which we are going to discuss, it is a transparent bridges. Okay, so we are going to discuss the transparent bridges. Now here, when we are going to talk about the transparent bridges, frames must be forwarded from one station to another. And here, the forwarding table is automatically made by learning frame movements in the network. Okay, loops in the system must be prevented. See, these loops should not occur. Okay, so now how it is going to be happen? Now here, if we are going to look at that example, your 15.6. Okay, when we are going to look at what is going to be happen, so when whether it is visible, or shall I increase little size? Now here you can have a look at it. When station A sends a frame to station D, okay, the bridge does not have an entry for the either D or A in the first one. Then the frame goes out from all three ports, and the frame floats the network, and by looking at the source addresses, the bridge learns that station A must be connected to the LAN connected to port 1, and this means that frame destined for A in the future must be sent out through port 1. and the bridge adds this entry to its table, and the table has its first entry now that you can have a look at over here. Initially it is not having anything, after that it has learned and it is added. Now next what we are going to talk about, so when station E sends a frame to station A, the bridge has an entry for A. Okay, so it forwards the frame only to port 1 and there is no flooding. In addition, it uses the source address of the frame E to add a second entry in the table. Now here if you are going to look at that, okay, so when after A sends to the frame to D, it has learned, okay, future all A need to be sent to 1. When it is sending from E, when after E sends a frame to A, now what happened? It has learned E has connected to the port 3 and it made a entry, and whenever E is sending to A, it is taking and it is looking at that and it is forwarding it to port 1. Okay. Now after B sends the frame to C, now here if you are going to look at that, B is over here and B is sending the frame to C. Now it is understanding that, okay, now the B also is connected to 1 and it is making an entry. Okay, so now this is what exactly is going to be happen, but we are going to have sometimes the loop problem in the learning bridge. Okay, what is the meaning of a loop? Now the point is, always see when A is sending to D, so it is giving the A to D and it is sending to the bridge. Okay, now so this is what exactly station A sends frame to station D. But if you are going to look at that, both bridges forward the frame. Now here if you are going to look at that, A is sending, it is prepared a table, and here it is coming to this bridge 1, and the same way even in this one same thing, bridge 2 is also getting it. Okay, so now you see what is happening in this particular LAN 2, 2 copies of the frame on the LAN 2 is there. Okay, so at the same time what is happening, now you see both bridges forward the frame. Now again if it is forwarding the bridge 1, whatever it is going to get, it is forwarding it to the bridge 2. Okay, now what is happening, so here again the same thing, from the LAN 2 whenever it is coming to that, 2 copies of a frame on the LAN 1 it is coming back, because this is a different frame, this is a different LAN, this is a different LAN, whatever it is coming on this and it is going to send. This is flooding. What is the meaning of flooding? Flooding is nothing but whatever I am getting it, okay, except from which I am going to receive it, but remaining all I am going to make a duplicate and I will forward it. That is what we are going to call it as a flooding. Okay, so now here if you are going to look at that, the 2 copies on that particular thing. Now here if we are going to look at, okay, we are going to have the loop problem. See, transparent bridges works fine as long as there is no redundant bridges in the system. So now here, dear friends, if you are going to look at this, to connect these 2 networks, 1 bridge is enough. Why we need 2 bridges? Now you tell me, anyone can tell me that why we need 2 bridges? We don't require. So now that is, we have taken it as an example. See, when there are no redundant bridges, now you need to remove that. So however, like to have redundant bridges, why? See, system administrators will keep these redundant bridges. Why? If one bridge fail, another bridge will be there. See, more than one bridge between a pair of LANs to make the system more reliable, isn't it? Why they are going to keep it? So you may question it, sir, I need only 1 bridge is enough, but why we are keeping another bridge over there in the example? Now that point is quite simple. We are going to say that if a bridge fails, see, if a bridge fails, I want to make the network more reliable. So if a bridge fails, another bridge takes over until the failed one is repaired or replaced. But this redundancy can create loops in the system. Okay, so if these loops are there, then we are going to have a problem. Okay, so now that example which we have shown over here, so now there are 2 copies of the frame from LAN 2. The copy sent out by the bridge 1 is resolved by the bridge 2, and which does not have any information about the destination address D. So it floods the bridge. That is what I said, it floods the bridge, and the copy sent out by bridge 2. Now you see it, which is received on bridge 1, it is sending on the bridge 2, is received by bridge 1 and is sent out for lack of information about D, and ultimately what is going to be happen, a loop is going to be done, and once if this loop is once if the loop is there and each one is continuously forwarding, and then the network is going to be overloaded, and so simply we are going to have a collision. So in that particular situation we are going to use CSMA by CD. That is the reason starting of the class I said this Ethernet is going to make use of the CSMA by CD. Okay, so the tables of both bridges are updated, but still there is no information for the destination D. So in that particular situations we may get this particular loop. So we need to solve this particular problem. Okay, so how we are going to solve this looping problem? By using the spanning tree algorithm. By using spanning tree algorithm. What is the meaning of spanning tree algorithm? Just to create a loopless technology. In the data structures you are going to do that. Okay, whenever you are going to draw a tree, okay, with the nodes, okay, if you are going to draw that particular tree nodes like this, now what you will do, you will remove this particular thing, okay, this particular link, so that you will never have a loop. So now the spanning tree algorithm is nothing but which is going to see that, okay, it allows you to visit each and every node, each and every station in the network, but nowhere you are supposed to have a loop. That is the reason we need to create a loopless topology. For that we are going to use the spanning tree algorithm. Okay, so this is the spanning tree which we are going to use. So as if you are going to look at, okay, so how we are going to do that particular thing. So then majorly we are going to create the shortest paths in that, and based on that only we are going to forward the data. Okay, so how this is going to be happen in that. So now here if you are going to look at that, so now this is an interconnecting with hubs, how you are going to do that. Okay, so each station is connected to these hubs, and these hubs are connected to the hub tree. Okay, this is, I can call it as a hub tree, and from that hub tree we are going to do that. See, backbone hub interconnects LAN segments and extends maximum distance between nodes, and but individual segment collisions domains become one large collision domain and cannot interconnect 10 base T and 10 base 100 base T over here, because these are the hubs, okay, which we cannot use the 10 base T and 100 base T's over here. Okay, so at the same time when we are going to talk about a switch, now here this is what I told that, which is going to have a store and forward of Ethernet frames, and so when the frame is to be forwarded to the segment, it uses the CSMA by CD to access management, and which is a transparent, it is going to maintain it as a transparent. So what is the meaning of transparent? Transparent is nothing but host is not aware of anything, okay, unaware of presence of switches. And so this is the one mechanism, and another one I told that two types of learning. One is the transparent, okay, another one is the plug and play or self-learning. Okay, so transparent is one and plug and play is one. So switches do not need to be configured, just have a plug and play. So this is another one. So now how this is going to be forwarded? So you are going to have 1, 2, 3 ports. Based on that you are going to create a hash indexed table. Okay, so how to determine onto which LAN segment to forward the frame. So now here you are going to use routing problem. So here we are going to use the self-learning. So in the self-learning, so it is going to learn that, okay, so where to send and all. So now here if you are going to look at that, a switch has a switch table, that is a hash table in the, so which I mentioned that just now. So entries in the switch table, what you are going to have, MAC addresses and which interface and the timestamp, this you are going to have it. And so if you are going to say that stale entries in table drop TTL can be 60 minutes. Okay, so this is nothing but time to leave. You can verify and you can construct. We will come back to that in the practical time to leave fields. Okay, how you are going to do that. So when a frame is received, switch learns location of sender, incoming LAN segment, and then it records that sender location and the pair in the switch table. That is what we have seen. That is in the self-learning mode, which is going to be happen. Then forwarding. how it is going to be forwarded. It is going to verify with that particular MAC addresses and which port it is connected from the table. It will learn and it will forward according to that. Okay. Now here, if you are going to look at an example, suppose C sends a frame to D. Where is the C? Over here. So where is D? Over here. So now here, if you are going to look at that, switch receives frame from C. Okay. Notes in a switch table that C is on interface 1. Okay. In the switch, it is going to identify that C is on the switch 1. Okay. And because D is not in table, B is not in table. Okay. What it is going to do? Switch forward frame into interfaces 2 and 3. Interfaces 2 and 3. Okay. So then once if it is came to 2 in the 2 who are connected DEF. So D is receiving it, the frame is received by D. Now this is the way how it is going to be forwarding it to that. Okay. So when you are going to talk about a switch example, now here if you are going to that, suppose D replies back with frame to C. So now here D is over here, C is over here. Now switch receives frame from D. Your switch is going to receive. See here the difference is here also the switch. Okay. Now C to D and D to C. Now there it was learned. So next when D is replying back to C, now what is happening? Switch receives the frame from D. Okay. Then notes in switch table the D is on interface 2. D is on interface 2, and because C is in table, C is in table, because already it is received, it is added. Okay. C is on 1. Okay. So switch forward frame only to interface 1. So previously what happened? It has sent to 2 and 3, I said. See, it has received it and it has sent on 2 and it has sent on 3, even though it is not there on that. Okay. So, but here when replies is coming, that you are going to get this particular thing, and then accordingly only it is going to forward it to that. So the frame is received by C over here. Okay. So looping problem, which already I have explained. So how it is going to be happen? Now you see, then here if you are going to look at that, see, I can use that L1 to see B2, B3, L3, B1, L1. Now you see loop is formed. When loop is formed, when I want to remove the loop, then I to remove, okay, these things. Now you can have a look at over here. It is dotted lines, it is removed. Okay, when I am removing it, I am able to reach all L1, L2, L3, L4. Okay, but the point is there is no loops. Okay, so you need to create the spanning tree algorithm. You have to apply that to see that your network should not have any loops. Okay, so now how you are going to isolate your traffic? Okay, so same LAN segment frames are become separate things where you are going to have a collision domains. Okay, so each one you are going to call this as a collision domain, this as a collision domain, this as a collision domain, and these collision domains are going to be connected. Then you are going to call those things as a VLANs, virtual LANs. Okay, which we are going to discuss that. Okay, so this is how exactly which is going to be happen in the switching. Okay, so this is what how exactly you are going to create your backbones. Okay, and all. So I hope every one of you have understood this concept. Very interesting one. Okay, how exactly it is going to be used. Okay, any doubts? So this data link layer switching, we are going to make use of that, and we will finish it off with the wireless LAN in the tomorrow's class. Okay, so if everything is fine, okay, so I would wish you good luck. Prepare well for your exams. And I have already shared the assignment questions. Please write and submit it on the day of exam. Thank you. Any queries?
Sir,
Yeah.